Welcome to Lesson 28, Solving Systems of Equations by Elimination. Before we begin today's lesson, let's look at our key vocabulary words. Systems of equations, a set of two or more equations that contain two or more variables. Solution of a system of equations, a set of values that are solutions of all of the equations. So today we're going to learn how to solve a system of equations by eliminating one of the variables. Let's look at another slide together. You can solve a system of equations for either variable. It's easiest to solve for the variable that has a coefficient of 1. If the coefficient is positive, you would simply subtract. If the coefficient is negative, you would add to eliminate. So let's look at our first example. We have x minus 1 is equal to negative 3, and then we have x plus 4y is equal to 12. So the slide that we just read stated that you can eliminate a positive x by subtracting. You can eliminate a negative y by adding. So let's notice our coefficients of these equations. They're both 1 for x. So we have a positive 1x, positive 1x. For y, we have a negative 1 and a positive 4. So when we are trying to solve systems of equations by eliminating, we always want to choose to eliminate the variables that have the coefficient of 1. So we have a positive 1 here and a positive 1 here. How would you get those to eliminate? You would subtract. So when you subtract x minus x, it eliminates, it cancels. And then we'll have to go through and do a little bit of math. Negative 1 minus 4 would give us negative 5y. Negative 3 minus 12 would give us negative 15. So now we're left with a one-step equation. So what once looked very complicated is now just a one-step equation. So they're multiplying both sides by negative 5. We're going to divide both sides by negative 5. So now I have found my value of y. Y is equal to 3. How do I find my x? I simply choose one of my equations to substitute in the value of x for. And I'm going to choose x minus y is equal to negative 3. Okay? It didn't matter which one I chose. I just happened to choose the top one. And then I would substitute what y is, which is 3. So x minus 3 is equal to negative 3. And notice I used parentheses, okay? It's important to use parentheses. It keeps you from messing up what the original value of y is. Okay, so x minus 3 is equal to negative 3. So what I'm going to do is I'm going to simply solve this one-step equation and look at what happens, okay? Look at what happens. This eliminates, and I'm left with x is equal to 0. Is it okay to have a value of 0? Absolutely. So for my ordered pair, I would have 0 and 3. And what that means is I could plug in 0 for x and 3 for y and get a true statement in both of those equations. And we'll do one just for practice. So if I would choose the top one, okay, x was 0, y was 3. Is 0 minus 3 negative 3? Yes. Again, just to reinforce this, I'll use the bottom one. So I have x, which is 0, plus 4 times y is 3 is equal to 12. And does that check? Absolutely. Again, that's how you can check your solution to make sure you're correct. Okay, so let's move on to our next example. Okay. All right, let's move on to another example. All right, x minus y is equal to 3, and x plus y is equal to 5. Now, in this example, our coefficients for x and y are both 1. So we could choose to eliminate x, we could choose to eliminate y. At the end of this lesson, I have done it both ways, but just to save us for some time, I'm going to eliminate my y's. How could I do that? Well, one's negative, one's positive, so if I would add those together, they're going to cancel. Negative 1 plus 1 is 0, cancels out. And I'm left with x plus x, which is 2x. 3 plus 5, which is 8. Okay? Again, what was once complicated turns into a one-step equation. I'm going to divide both sides by 2. X is equal to 4. And then I choose one of my original equations to substitute what x is equal to. I'm going to choose the bottom one. X plus y is equal to 5. So I'm going to sub in 4 for x. So 4 plus y is equal to 5. Just to show you the steps of solving this equation, I would go ahead and subtract 4. Y is equal to 1. Okay? So when I put my x and my y together, I have 4, comma 1. Ordered pairs are always listed in parentheses. So this is my solution. Again, how would we check to make sure we're correct? We would substitute in 4 and 1 into either one of those equations. Okay? All right, so I hope you're hanging in there, and I actually feel like this is easier than what we did in the previous lesson, how we solved systems of equations by substituting. Okay? All right, so let's go on to our next example. This time we have 5x plus 5y is equal to 5. Okay, a lot of 5's in there. And, I'm sorry, negative 5. And we also have 5x minus 5y is equal to 25. Okay, so I chose to use a lot of 5's. It's okay, it's still going to work out. Do I want to eliminate my 5x's or my 5y's? Again, they both have the same coefficient. If I would subtract here, I would eliminate my x's. If I would add, I would eliminate my y's. So I'm going to subtract, and I'm going to eliminate my x's. 5x minus 5x is 0. It cancels. 5 minus negative 5. Let's think about that. 5 minus negative 5. Leave it, add it, change it. So look at what I'm left with. I'm really left with 10. So be careful with your integer rules. And like I came off to the side, 5 minus negative 5. If you need to do that while you're solving these equations, it's no big deal. Okay, so leave it, add it, change it. Gives us a 10y. Okay? Negative 5 minus 25. Negative 5 minus 25. Leave it, add it, change it. Well, that would leave us with a negative 30. Okay? And then when I do the steps, I divide both sides by 10. I'm left with y is equal to negative 3. I need to keep going, and I need to solve for my x. Okay? Choose one of my original equations. I'll just choose the top one. 5x plus 5y equals negative 5. Substitute in my negative 3 for my y. 5x plus 5 times negative 3 equals negative 5. Okay? Go through, do the math. 5x minus 15 equals negative 5. Okay, they're subtracting 15. I'm going to add 15. Okay, 5x is now equal to a positive 10. You guys see that? Divide both sides by 5. X is equal to 2. So now I have my y, I have my x. Make sure you put them in the correct order. X always goes up front. Okay, so we just now solved another systems of equations. We have one more to go, and then we'll wrap this lesson up. Okay? Again, I hope you're hanging in there and that this is not complicated for you. If you feel like I'm moving a little bit too quick, just sort of rewind and watch this lesson again. Okay? So we've got 4x minus y is equal to 20. And we also have negative 5x plus y is equal to 2. Oh, negative 2. Okay. So we have those two systems of equations. I'm sorry, these equations together makes up our system of equations. So let's look and see which ones have a 1 for their coefficient. Would it be my x's or my y's? Well, x has 4 and it also has a negative 5. So we're going to choose to eliminate our y's. One's negative, one's positive. So we would have to add these two equations to eliminate our y's. Okay? 4 plus negative 5 is negative 1, okay, negative 1x. These guys eliminate, and I'm left with 20 plus negative 2, which is 18. You guys see that? So 4 plus negative 5 gave us a negative 1. And now what do you know about a negative variable? A negative variable cannot happen, so you'd have to switch everything to its opposite. You guys notice that? You have to switch everything to their opposite. So now I have the value of x. I need to plug that into one of my original equations to find my value of y. I'm going to choose my top one. 4x minus y is equal to 20. Okay? I would plug in negative 18 for x. All right? What is 4 times 18? Well, I could come off to the side. 32, 3, 72. So I'd have negative 72 minus y is equal to 20. Okay? I would have to add 72 to both sides. Okay? I'm left with negative y equals 92. And look, there's that negative variable again. Change everything to that's opposite, and now we have our value of y. So I have negative 18 for x, negative 92 for y. Is it okay that we had such large numbers? Absolutely. That wraps up our lesson on solving systems of equations by elimination. I'll see you in the next lesson.